Now that we've worked through a couple of basic examples, I want to show you what we do if we have an x, a variable, on both sides. Things get a little more complicated, but it's still not too bad. It's things that we have done before, just putting them together in a little bit different way. And so I want to look at my equation, x plus 1 on one side and square root of 7x plus 15 on the other side. Let's remind ourselves that this is a square root, or an index of 2, and notice that my radical is already isolated on this side. So we are ready to go ahead and use squaring to undo the square roots. Here's where you have to be a little bit careful. This says x plus 1 squared. That doesn't mean take x and square it and add 1 squared. Remember, it means the whole thing in parentheses multiplied by the whole thing in parentheses. So this can be rewritten, and should be, as x plus 1 times x plus 1. That's looking like a multiplication problem to me. We'll take care of that in a minute. And my square root and squared cancel, leaving me with 7x plus 15. Now I mentioned multiplication. Let's go ahead and multiply this out. This is like the factored form of a quadratic, and we want to write it in standard form instead, things we've done before. Let's go ahead and do box method. You could do distribution if you prefer. Remember that you just write each piece on the outside, and we're going to work our way to the inside, writing what the result or the product of the multiplication is. So x times x is x squared, x times 1 is x, another 1 times x is x, 1 times 1 is 1. We can combine some like terms. I see 2 x's here, so I can say x squared plus 2x plus 1 as my quadratic or polynomial. I'm going to bring that back up here and rewrite as x squared plus 2x plus 1, and that's equal to 7x plus 15. We need to continue solving, and so to do that, I notice that I have an x squared, and I'm going to have to deal with that by solving a quadratic. But the first thing that we need to do when solving a quadratic is get it equal to 0 on one side. That means that I need to subtract 7x from both sides, and I need to subtract 15 from both sides. That will cancel, leaving me with just a 0 here. I'm going to have x squared minus 5x minus 14. And now we can use our Xbox method to continue solving. So let's come down here, and remember that the top of our box is going to be our a times c coefficients. Well, the coefficient in front of x squared is just a 1, and then times negative 14 will give me negative 14. Remember, this is a times c. Then the bottom of my x needs to be the b term, that middle term, which is a 5. So I am looking for factors of negative 14 that add to negative 5. Since my number I'm adding to is negative, that means the bigger number needs to be negative. And since I always write my small numbers on the left, I'll write my negative on the right. 1 and 14, or negative 14, is one set of factors. 2 and negative 7 is the other. And it's the 2 and negative 7 that are going to add to be negative 5. We can then fill in our box of our x box. First term here, last term here, and then our new factors that we just found, 2x and minus 7x, and we want to find a greatest common factor along each row and then each column. So x squared and negative 7x is going to be an x. 2x and negative 14 will be a 2. Going down, x squared and 2x, that will be an x. Negative 7x and negative 14, well, that will be negative 7. So I can rewrite this in factored form as x plus 2 and x minus 7, and that's all going to equal 0. Now I want to solve. I'm going to set each of these pieces equal to 0. So x plus 2 equals 0, or x minus 7 equals 0. And if I add 7 to both sides here, I will get that x is equal to 7, and over here I'll subtract 2 from both sides and get x is equal to negative 2. Now remember, we have to check these. So let's go ahead and do that. First, I will take one of my x values and plug it in everywhere that I see x, which is in 2 different places in my original equation, and then I need to check the other one as well. So let's go ahead and check the 7 first. So remember, it was x plus 1, so that's going to give me 7 plus 1, and that's going to be equal to the square root of 7 times 7, again substituting for x, plus 15, and we want to continue solving. 8 is equal to 49 plus 15, which is 64, and the square root of 64 is 8, so 8 is equal to 8, and we are good. That means that we can take that 7 and box it as a final answer. Let's check negative 2 now. So now, instead of substituting a 7, I'll substitute negative 2 everywhere I see x. Negative 2 plus 1 is equal to the square root of 7 times negative 2 plus 15. Negative 2 plus 1 is negative 1, and I have negative 14 plus 15, which is going to give me square root of 1, and the square root of 1 is 1. This is not equal. Let's put a big ol' X by that. Negative 1 is definitely not equal to 1, so we are going to cross out this negative 2 and say that it's extraneous.